All right, so just two more examples here to talk again more about like finding antiderivatives. And if you read through this, it says, basically it just tells us what we've been thinking about these problems. Suppose the derivative for some function is this, right? Derivative is that. Find the original function. So go backwards. So we can apply that antiderivative symbol, right? And solve this problem, saying, okay, let's find this antiderivative, so of x squared minus 1 with respect to x. And so just using the power rule, so that's a 2, so we bump it up a power to 3, and we make that a 3. And then this was just a linear function minus x, and then some constant. We don't know what that constant is yet. So here's our original function, right? You can always check its derivative, super simple. 3 times, the 3 comes down, cancels that 3, just x squared minus 1. The constant will go away. And normally that's it. That's where we would stop. But this one also says, hey, there's a point here. When x is 3, y is negative 5. So I can actually solve this problem for that constant. Like, it's not just any particular solution. It's the one solution that actually goes through this point. So then I get negative 5 equals 27 over 3, which is 9, minus 3, plus constant, that's 6. So then I get negative 5 equals 6 plus the constant, or negative 11 equals my constant. So once I know that, I can then say it's not just any function, it's particularly, there it is, 1/3 x cubed minus x minus 11. That is our given function. It'll go through that corresponding point. Okay. Same thing here, number 7, just another example. Here's our derivative. Here it is. Go back to the original function. So then if I do its antiderivative of 2x, and remember the square root is just the 1/2 power. So we can think of that as a power and apply the power rule. So we bump it up a power. So it's 2x squared divided by 2, or the 2's would cancel, it's just x squared. Oops. And then the square root, remember that being a 1/2 power, so that's x to the 3/2 divided by 3/2 plus some constant. That is what y equals. And I'm choosing y equals instead of f of x, only because that's the notation. And so let's simplify this here. So y equals x squared plus 2/3, if I flip that around, x to 3/2 is the same thing as x root x plus constant. And then let's put a particular point in. 11 is equal to 4 squared of 16 plus 2/3 times 4 root 4 plus our constant. And so then, so we could subtract the 16, so that's negative 5 equals, that's 8/3 times 2, so 16/3 plus our constant. And then, we can subtract 16/3 here. This is the same thing, negative 5, if you think about it in terms of a third, it's negative 15/3. So we subtract 16/3 to get our constant, which is negative 31/3. So then we could say our function y is equal to x squared plus 2/3 x root x minus 31/3. And there's our function. So just another way to ask the same question. Find a function whose derivative is this, and that's just the antiderivative. This sometimes also has like what's called an initial condition. We know one condition that allows us to find for that c value. If you don't know it, then you just have to leave it as a generalized function with that plus c.